The whole AI revolution, it really boils down to two key ingredients: incredibly smart people and insanely powerful tools. So today, we're going to pull back the curtain and look at both. We'll see who is actually building our AI future, and maybe even more importantly, what exactly are they building it with?
All right, let's just jump right in with a number that kind of tells the whole story. $300,000 to $700,000. That's the kind of annual salary we're talking about for a top AI engineer. So why so much? Well, it's because in this new economy, these folks aren't just writing code, they're literally the architects of our future. And the demand for what they can do, it is absolutely through the roof. Yeah, that salary, it really reflects what they do. Think of them as the crucial link, right? The bridge between some super abstract, cutting-edge research paper and the actual, tangible AI tools that are already changing everything, from our healthcare system to just how we talk to each other every day. So if we're calling them architects, it begs the question, right? What's in their toolbox? What are the digital hammers and saws, the actual hardware that they're using to build this whole new world for us? Okay, before we can really get into the tools, we have to understand the bigger picture. And the best way to think about it is this. We are living through a full-blown AI gold rush. Seriously. This isn't just another tech fad. It's a massive economic shift, and it's creating a totally new world that needs, well, a totally new kind of architect.
And I mean, just look at the money here. The global AI market is set to more than quadruple in just 6 years. We're talking going from about $184 billion now to over $826 billion by 2030. That kind of explosive growth is the rocket fuel for this entire revolution.
And this quote right here, it just nails the role of the engineer in this gold rush. They are where innovation meets industry. It's like they're taking the theoretical gold, the brilliant ideas from research papers, and literally forging it into the real-world products that you and I actually use. But, to forge gold, you need a seriously powerful furnace. So what's the engine driving this whole multi-billion-dollar machine? It all comes down to one single thing: massive, and I mean immense, computational power.
And that brings us right to the engineer's #1 power tool, the GPU. The graphics processing unit. It's kind of funny. These things were originally made for video games, to make them look pretty. But it turns out their ability to do a bazillion calculations all at once makes them the perfect tool for training the giant AI models that are changing everything.
But here's where we hit a massive problem, a huge gap. On one side, you've got the absolute titans, the enterprise GPUs like NVIDIA's H100. They're the best of the best, top-tier performance, but they are insanely expensive and almost impossible for a regular person to get their hands on. Then, on the other side, you have the best consumer GPUs, like the RTX 4090. They're way more affordable, you can actually buy one, and honestly, the performance is phenomenal for the price.
So this sets up a really interesting challenge, right? What if you're a startup or a researcher or just a really ambitious developer? How do you get your hands on that elite-level power if you don't have a Google-sized budget? How do you even get in the game?
Well, the answer is just pure, brilliant engineering. You see, instead of trying to buy a supercomputer, they're building one. They're bridging that massive power gap with some incredibly clever design and parts that, well, you might be surprised how accessible they are.
So here's the solution, and it was pioneered by teams like the one over at the VC firm Andreessen Horowitz. The big idea is to take consumer hardware and just push it to the absolute edge. They take 8, count them, 8 of the most powerful consumer GPUs you can buy, these RTX 4090s, and they cram them all together into one custom-built server. What you end up with is an absolute beast of a machine.
Now, to really get why this is so clever, you got to understand one quick tech concept: PCIe lanes. The easiest way to think about them is like data highways. For a GPU to run at full throttle, it needs its own private, super-wide, 16-lane highway straight to the processor. So the real engineering puzzle here is how do you get 8 of these massive highways running right next to each other without causing one giant traffic jam?
And get this, these are the actual parts they're using. You can go out and buy this stuff. The backbone is an ASUS server. All the muscle comes from those 8 NVIDIA RTX 4090s. The brains are 2 super powerful AMD server CPUs, and it's all held together with a whopping 384 gigs of high-speed RAM. This isn't some fantasy machine, it's basically a shopping list. Okay, but here's the real magic trick. It's all in how they physically put it together. First, they actually separate the PCIe boards, that's where the GPUs plug in, from the main motherboard.
Then they build this custom frame that sits on top to hold 4 of the GPUs outside the main box. And why do all this? Because it lets all 8 GPUs plug in directly, without using those slow, clunky extender cables that kill performance in so many other builds.
When you get right down to it, this whole build is just a brilliant solution to a surprisingly simple physical puzzle. See, the RTX 4090 card is huge. It's a triple-slot behemoth. There is no way you can physically fit 8 of them in a normal server case. So this custom 2-story frame, that's the key. That's what unlocks the whole thing and makes it work, all while keeping those data highways running at full speed.
Okay, so we've got the parts, we've got the Kleber setup, but what's the big deal? What can you actually do with a personal supercomputer? Well, this is where things get really, really interesting.
What this gives you is basically your own private AI laboratory. You could build a custom coding assistant just for you, or create a personal chatbot that's trained only on your own files and emails. You can play around with the most powerful open-source AI models out there, like Llama or Mistral. But here's the absolute game changer. You can do all of it in total privacy. Your data never leaves your machine. No cloud sharing, no data leakage. It's all yours.
And look, this isn't just for hobby projects. This kind of raw computing power is already shaking up entire industries. Take healthcare. Places like the Mayo Clinic are using it to comb through patient data, trying to predict diseases before they ever become life-threatening.
Or how about finance? This power is what's running behind the scenes doing real-time fraud detection. Think about a company like PayPal. They're processing millions of transactions, and it's AI models running on powerful GPUs that can spot a weird pattern in a split second. We're talking about saving people and businesses billions of dollars.
And then there's retail, where it's basically a crystal ball. A company like Zara can feed it mountains of data, sales figures, social media buzz, what's happening on the fashion runways, and it can predict, with spooky accuracy, what you're going to want to wear next season.
So what does all of this add up to? It points to one huge final idea. The future of AI might just be homemade. What we're really seeing here is the democratization of AI power. It's being put into the hands of more and more people.
Because of clever solutions just like the one we've been looking at, the most powerful tools for building the future are no longer locked away in the giant data centers of just a handful of tech corporations. Now, they're within reach for startups, for researchers, even for passionate individuals.
And that leaves us with one last big question. For really the first time ever, supercomputer-level power is available to anyone with enough creativity and determination. So the question isn't just what problems they are going to solve next. The real question is, if you had this kind of power, what problem would you solve?